Okay, here's some more sum formulas. Here's looks like it says it's an infinite series, so this goes on forever and ever. Clearly, our common ratio is 2 radical 2. So our first term is 2 radical 2. Our common ratio, it's not quite that clear, so I'm going to do 8 divided by 2 radical 2. So I'm going to simplify. 8 divided by 2 is 4, so 4 over 2 radical 2. And then I'm going to simplify this, and so I'm going to multiply by radical 2 over radical 2. So that gives me 4 radical 2 over 2, which is the same as 2 radical 2. So our infinite series would be 2 radical 2 over 1 minus 2 radical 2. We could leave it in this form, but if you notice, my denominator here is going to be negative because 2 radical 2 is larger than 1. So this sum would be less than 0 because this numerator is positive and the denominator is negative. My sum is negative, and all these terms are positive, so that doesn't make any sense. So if we consider our common ratio, since our common ratio is larger than 1, we can't find this sum. So that's a hint. If your sum is negative and they're all positive terms, then you have an issue. So since our common ratio is too large, we can't find the infinite sum. So the next one has some complex numbers mixed in it. Doesn't really change the problem very much. Our common ratio is pretty clear. It would multiply times what gives you I over 2. That would just be I over 2. So our common ratio is I over 2, and our first term is 1. So our infinite sum is equal to 1 over 1 minus I over 2. And I'm going to get rid of this denominator by multiplying top and bottom by the common denominator. Well, there's only one denominator in this whole thing, which is 2. So I'm going to multiply the whole numerator and the whole denominator by 2. Well, 2 times 1 is 2. So that gives me 2. And then I multiply 2 times 1, which is 2, and 2 times I over 2, which is negative I. I'm in the rationalizing mood, so I'm going to multiply the numerator and denominator by the conjugate. So my sum is now, distributing this 2, I get 4 plus 2i. Nice thing about multiplying by the conjugate is you don't have a middle term, so this is just 4 minus I squared. And if you remember, the square root of negative 1 is equal to I squared. If you square this, you get negative 1. I cubed, if you multiply both sides of this by I, you get negative I. And I to the fourth is if you square both sides, you get 1. And then, I to the fifth, make that look like an I, is the same as I times I to the fourth. So that's just equal to I, which is back to the beginning. So it's cyclical. So I squared is negative 1, so therefore our sum will be 4 plus 2i over 4, I'm going to change that to minus negative 1, obviously those two change. So our denominator, is 5. Our next one this is a geometric sum. It's infinite, going on forever. We want to determine what is the value of x. Well, since it's infinite, we can use our infinite geometric sum formula, where the sum is 2, the first term is 1, and it looks like we're multiplying each term by x squared. So our infinite sum will be 1 over 1 minus x squared, which is equal to 2. So if we just do some algebra, we'll figure out what the x value is. So multiply both sides by 1 minus x squared gives me 1 equals 2 minus 2x squared. Subtracting 1 gives me negative 1. Dividing by negative 2 gives me a half equals x squared. So x equals plus or minus the square root of 1/2. Taking the square root of the numerator gives me 1. Square root of the denominator is just the square root of 2. And I'm okay with having radicals in the denominator in this problem. Our last problem is we have a chain letter that I used to get back in elementary school. If the first person writes 5 letters, instructing each recipient to write 5 more letters, then these people are to send 5 more letters to other people, and the pattern continues. So the a sub 1 would be 5, and then the next group needs to write another 5, so that would be, so our first term would be 5, the next one would be 25, and then these people need to write 5 letters, so that's 125, and then these people need to write another 5 letters, so that's 625. So clearly our common ratio here is 5, and our first term is 5. We want to pretend that this happens 12 times. So our finite sum, this is not infinite, it's finite. 5, 1 minus 5 to the 12th, all over 1 minus 5, courtesy of my calculator, is 305175780.